Good morning. Happy Monday, guys. It's into the last week here in the home stretch here. Okay, today is June 8th here. We're going to be talking about dividing unit fractions by whole numbers. Okay, so kind of flip the divisor dividend from what we've been working on. Let's see here. Again, we're doing page 475, 478 to 480. If you watch this video through together, you're going to see that I'm going to do a bunch of this to guide you through and teach you how to do it, then leave you just a little bit to do on your own. So it behooves you to watch it so we can do this together to free you up. It won't take us that long, 15 minutes or so, and then you guys will be able to finish up fairly quickly. So again, we are dividing a unit fraction by a whole number. Okay, let's look at the problem here. It says Piper uses 1/6 yard of ribbon to make a border around an equilateral triangle. How long is the piece of ribbon that Piper uses for each side? So she's using 1/6 yard of ribbon to make a border around an equilateral triangle. Now this is not saying that each side is 1/6. It's saying that she has a total of 1/6 of a yard. Okay, so 1/6 yard of ribbon, and then she's going to use that to make a border. Now this is going to be around an equilateral triangle. An equilateral triangle has all three sides are equivalent, correct? So therefore, all three sides are going to be equal. So we need to figure out how much she'll have in order to do this. So the idea is that we're going to have 1/6 of a yard. That 1/6 of the yard we're going to divide by 3. We're going to divide by 3 because an equilateral has 3 equal sides, and that's our answer. Our answer is going to be how long the piece, each piece is, right, on each side. Okay, so let's go ahead and model this, see what this looks like. Now, I don't need to draw an equilateral triangle to model this. I just need to model this problem, right? So first of all, I want to show what I have. I always want to show what I start with when I'm talking about division. So what I start with here, I'm going to draw this as, I'm going to say that this is 1 yard. Okay, that's what this square is representing 1 yard. Okay, we're going to break this into sixths. So we're going to draw 5 lines, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5, 6 parts, and we have 1/6, correct? So this is what our 1/6. This is what we have. We have 1/6. Now we're going to divide this into 3 parts. So therefore, we're going to go ahead and using the same strategies we've been using, right? This isn't anything crazy here. Okay, we're breaking 1/6 now into 3 parts. So now I broke it into 3 parts, right? So this is essentially side 1, this would be side 2, and this would be side 3 of the triangle, right? So question is, how long is the piece of ribbon that Piper uses for each side? So all of 3 of these are the same size, correct? So the idea is, what is the size of one of these, right? What is that size of that square right there? Okay, well, it's obviously one part of 1, 2, 3, 4, 5, 6, because that's my denominator, right? Then 1, 2, 3, because that's how many parts it's been broken up to, so it's going to be 18. So it's going to be 1/18 yard. Okay. Well, let's think about this using the concepts we've been talking about with multiplication. How can I take 1/6 divided by 3? How can I write this as a multiplication problem? It's going to be 1/6 times what? Well, as we talked about, if I divide by 1/10, it's the same as multiplying by 10. If I divide by 10, it's the same as multiplying by 1/10. So it's going to be the same here, right? 1/6 divided by 3 is going to be the same as 1/6 times 1/3. Now, if we check this using our multiplication strategy, 1 times 1 is 1, 6 times 3 is 18. I get the same answer, to check my modeling, right? Okay, pretty straightforward at this point. We've been doing this. So on page 476, you don't have to do that, but on page 476, you can see modeling of different ways to model this, to look at this as well. It's going through the same stuff I'm talking about though. We do not need to do this according to our pacing guide. We're just going to jump to, go to 478. We're going to do 478, 478, 479, and 480. Those are the pages that we're going to do and get practice in. So I'm going to go ahead and do this page with you and guide you through some more problem solving here. Again, watch the video, pay attention, and this will slowly make more and more sense for you. Okay, here we go. We have Felipe. He has 1/4 of a pizza. He wants to share it equally with his friends. How much of the whole pizza will, with a friend, how much of the whole pizza will each of them get? So there's two of them, him and a friend, so there's two of them. We have 1/4 of the pizza. Now, you might be tempted to draw the pizza as far as in a circle, which you could do. I don't recommend it because I think it's easier to just show 1/4 this way, show 1/4 this way, right? Okay. We're going to divide this amongst two people, so it means we're going to divide this in half. Okay, and this is Felipe, this is Felipe, and this is friend. Okay, so the idea is how much does each person get? Each person gets this amount, right? Which is 1 out of 8. Okay, so the idea is that 1/4 divided by 2 equals 1/8. We could use multiplication to solve this as well. We could use this as 1/4 times 1/2 equals 1/8 as well. Okay. All right. Let's keep moving. Okay. Number 7 here. Obviously, you can pause this since I'm going kind of quickly. You can pause this as you need to. Angela uses 1/3 of her rectangular flower garden for roses. She plants equal rectangular areas of red, white, pink, and orange roses in this part of the garden. What fraction of the whole garden has red roses? Draw a model and write an equation. All right, to represent the problem. Okay, so here we go. So 1/3 of her rectangular garden. So we're going to go draw a rectangular garden. Here is a rectangular garden. Okay, doesn't really matter. 1/3 of it, so we're going to break this into thirds. This is going to be roses. Okay, it's going to be roses, and it's going to use a lighter color. We're going to break this down. Okay, that's 1/3, 1/3 for roses. Okay. Now, she plants equal rectangular areas of this 1/3, okay, that are red, white, pink, and orange. Well, there's how many colors here? There's gonna be a section for red, that's 1, white 2, pink 3, orange 4. So we're gonna have 4 different sections that are gonna be equal in size within this, okay? So that means we need to go ahead and we need to divide this and give each one of them their equal space. So we're going to break this into fourths or into 4 parts. Boom. 1, 2, 3, 4. So again, this is going to be red. This is going to be white. This is going to be pink. This is going to be orange, right? Okay. So what fraction of the whole garden has red roses? Well, there's the red, right? This is my red roses right here. So what fraction of this has red roses? Well, it's going to be 1, obviously, right? 1 out of, well, again, this is a 4 by 3, so it's going to be twelfths. Okay, 4 times 3 is 12, so I have twelfths here. So my problem, again, I need to write an equation. So it's 1/3 divided by 4 equals 1/12. Okay, I can also write this as a multiplication problem, which would be, oop, we're not going to do that. That's actually down here. I forgot. Down here, this is the question for this one. So, which multiplication expression can be used to represent the situation or check the division expression or equation for this problem? So here's where we're going to use the multiplication, right? As I was about to say, again, dividing by 4 is the same as multiplying by 1/4, right? Okay. Think about it as the reciprocal. This is equal to 4, right? The reciprocal means it's flipped, right? Would be 1/4. So that's essentially what we're going to do. There's a saying that you're going to use eventually called keep, flip, change that someone's going to teach you at some point. It means within the problem, if it's 1/3 divided by 4, you're going to keep, you're going to flip, and you're going to change, or keep, sorry, you're going to keep, change, flip, okay? Keep, change, flip. So you're going to keep 1/3, you're going to change this to the inverse operation, which would be multiplication, then you're going to flip. And when he says flip, because this is 4 over 1, right? 4 wholes, right? Well, if you flip 4 wholes, it becomes 1/4, okay? And so that's what we need. So therefore, this is what we're going to get right there, right? Okie dokie. All right. Ooh, wait a second. There's multiple answers here possibly. Which multiplication expressions can be used? Okay, so this one obviously can be used to solve it. So it says or to check as well. Okay. Well, if I was going to check this, I was going to do the inverse of this. Oops, I would have put the 1 there. Okay, if I was going to go the opposite direction here, I was going to multiply to check my work, right? I could multiply 12 times 4 to get 1/3, right? So that would work as well, wouldn't it? Mm-hmm. Okay. The other ones would not make sense. All right. Almost done. You guys have 2 pages here, a total of 5 problems. Okay, 5 problems. Let's look at this first part together, and then I'll free you up to do the rest of it on your own. Okay, Felicia makes a half gallon of fruit punch. She pours an equal amount into 8 glasses. What fraction of a gallon of fruit punch is in each glass? Okay, so again, here is 1/2, right? This whole box would show 1 gallon. She has half of a gallon. The blue part is half of a gallon. Here are all the glasses that they're poured equally into. So each glass, here's each glass. Each glass is showing how much is in each glass, is how much of a gallon is in each glass, right? Well, again, if you have a half and you divide it by 8, you're going to get 1/16 because there are 16 squares, and there's 1 shaded out of the total of 16 parts of the gallon, right? Okay, so what multiplication equation could we use to solve this? Again, if dividing by 8, if this is my equation, 1/2, if this says dividing by 8, the inverse of that would be multiplying by 1/8. And I can confirm this because we already know the answer is 1/16. We can confirm that 2 times 8 does equal 16, right? So therefore, this shows you how much easier it is just to flip that and multiply, right? Rather than actually going through the whole dividing process. Okay. Now down here it says, suppose Felicia has made 1/4 gallon of punch and poured and poured an equal amount into 8 glasses. What would the amount of each glass be more or less than 1/16? Explain how the model in the example would change to show this. So what this is asking us, if she made 1/4 of a gallon rather than 1/2 of a gallon, right? Okay. In this one, we got 1/16 as our answer. So we're going to be comparing this, essentially the answer to this problem, to what this would be, we don't actually have to do any math here. We can just think about how we're doing this to see if it makes logical sense. Let me ask you this, is 1/4 larger or smaller than 1/2? 1/4 versus 1/2. Well, 1/4 is smaller than 1/2, right? Okay, so if 1/4 is smaller, and then we divide that, if we divide that by 8, okay, then we're going to get 1/32, okay? And so therefore, it's going to be a smaller amount. Will the amount in each class be more or less than? It's going to be less than. It's going to be less than 1/16, right? Okay, because the idea is, now explain how the model would change. Well, the model is going to change because if this is 1 whole gallon, I'm going to make this into fourths instead, right? Now this is into fourths, isn't it? And this blue section, this second blue section right here, would not be shaded in. That would not be shaded in. Only this one would be shaded in, right? So therefore, this is 1 part out of 8 by 4, 32 parts, okay? So you can write your answer for that based on my explanation of it. Here's a model, talk about how the model would change. We would, instead of halves, we would have fourths. I would say that, right? Okay, therefore, 1/4 of, 1/4 of, 1/8 of 1/4, right? 1/8 of 1/4 is what this model would be showing, okay? And 1/8 of 1/4 is 1/32, because if we multiply 1/4 times 1/8, okay? You have 3 problems to do on your own here, okay? And if you watch the video, this stuff should be making sense and clicking. So, yep, good luck. You got this. I believe in you. Again, guys, finish strong here. We have 5 days left here, okay? 5 days left to work hard, finish strong, get everything done. Talk to you guys later. Bye.